Hello students, how are you? I am Manoj sir from AP. Today on square and square roots chapter, lecture number 4. So today what we'll do, first point is recapitulation of square root by different methods. So I'll discuss briefly different methods to find the square root that already we have discussed in the previous class. Yes. Second, word problems related to squares and square roots. We will practice few songs on squares and square roots. And third point is Pythagorean triplets. This is very important. And fourth point is triangular numbers and perfect square numbers. So these 4 points I will discuss one by one. Now, first point, recapitulation of square root by different methods. Find the value of root over of 1764. First method, using prime factorization method. Square root of 1764 using prime factorization method. That means we have to express this number as a product of prime factors. So what are the prime factors? First 2, 2, 8, 16, 2, 8, 16 and 2, 2, 4. Yes. Then again 2, 4, 4, 1, 3, that is 14, 7, again 3, 3 for the 12, 3, 9, 7, 7. So 2, 2, 3, 3 and 7 into 7. So first pairs, next pair, next pair. That means 2 into 3 into 7. That is 42 is the square root value. So this is prime factorization method. Now same sum we will do by long division method. Long division method 1764. Already I have discussed in the previous class what is long division method. We have to start pairing from this side. So 17 the first pair, square value 4 square is 16. So 4 we have to give, 1 remainder, next pair, try to remember. So 4 means 4 plus 4, 8 or double of 4. Then 4 here, so obviously 2. So 42 is the square root value. So by long division method, square root value 42. Yes. Now the third method, shortcut method. Same sum using shortcut method. What I told, the shortcut method, first 2 digit and you have to see the unit digit. Here 4. So that means in square root value, when I am writing the square root value, unit digit will be what? Since 4 is here, then unit digit will be either 2 or 8. 2 or 8. 2 or 8. But which one will be? That will decide later. Now 17. 17 we have to know in between which two square value. So obviously 4 square 16 and it is 5 square 25. So in between 4 square and 5 square. So that means we are 100% sure the tens digit will be 4. Now 2 or 8. Already we know the answer 42, but I am explaining why we will take 2. Why not 8? For that I told, so two numbers 42 and 48 In between these two numbers, we have to consider a number having unit digit 5. So obviously 45 is the number between 42 and 48. 45 is the number having unit digit is 5. Now I told to find the square value of it, and I told you easily you can find the square value. How? Now since 5 is here, so always the last two digit will be 25, and then leaving 5 the next part, what is the number? We have to multiply it by its next number. That means 4 here, and next number is 5. That means 4 into 5, 20 will be the result here. That means 2025 is the square value of 45. So 20, now this number and this number you have to check. Since this 1764 is this number is less than this, so you have to take the smaller value. If this number is more than this, then we have to take the larger digit. Is it clear? So according to this, 42 will be the answer, not 48. Is it clear? I think this part is clear. So briefly I have discussed 3 methods to find the square root of a number. Now, so recapitulation of square root by different methods, that part I have completed. Now second point, word problems related to squares and square roots. The first example, see, is 2352 2352 a perfect square? If not, find the smallest number by which this number must be multiplied so that the product is a perfect square, and also find the square root of the new number. That means first we have to check this number perfect square or not. 2352. Yes. How can you check? Now we have to factorize it. 2352. Divide by 2, 11, 22, 15, 7, 6. Again 2, 2, 5, 10. Yes. Now 17, that is 2, 8, 16, 2, 8, 16. Again 2, 29, 4. Again 2, 14, 7. Now 3, 3, 4, the 12, 3, 9, 7 and 7. So this number equals to 2 into 2 into 2 into 2 into 3 into 7 into 7. So that means when we are making a pair, we are seeing 3 is the lone factor. That means 3 is not pairing. So that means this is not a perfect square, because we know to make a perfect, to be a perfect square, all the prime factors should be paired. But since 3 is not pairing here, that means it is not a perfect square. So now find the smallest number by which this must be multiplied so that the product is a perfect square. So obviously 3, since 3 is the lone factor, so you have to multiply by 3. This is the least number. So you have to multiply by 3. Then it will be perfect square, because 1, 3 is shortest here. So when you are multiplying, then the new number is 3 to the 6, 3, 5 to the 15, 1 carry over, 69 plus 1. That is 7056 is the new number. Yes or no? Now question is, find the square root of the new number. So now we have to find the square root of new number. That easily we can find out. How? Now already we know the prime factors of this. Then 3 is multiplied, so that means 2 into 2 into 2, 3 into 3 now, because already we have multiplied by 1, 3. So now all the prime factors are paired, and we know from each pair we have to take one number. So that means the result is coming 84. Result is coming 84. Is it clear? Yes. Now, area of a square field is 8281 meter square. Find the length of its side. Example 2. Example 2, the area of a square field is 8281 meter square. Find the length of its side. So that means we know the area of a square field. So how can we find the length? If I take the square root of the area, then we can find the length. So basically we have to find the square root value. So length of the side, length of side equal to square root of 8281, and meter will be the unit because area unit is here meter square. So now to find the square root value we can follow any one method, long division method, prime factorization method or shortcut method. But generally we will use long division method, that will be easier for you. So 8 to 81 making a pair 82 first pair. So that means 9 square 81, 9 you have to take. So 181. Then 9, 18. So obviously 1. Yes. So 91 is the square root value. That means length of the side is 91 meter. I think this part is clear. Now example number 3. Example number 3, 10404 students are sitting in a lecture room in such a manner that there are as many students in a row as there are rows in a lecture room. How many students are there in each row of a lecture room? So try to understand the meaning of the question. Total students is 10,404. They are sitting in a lecture room in such a manner that there are as many students in a row as there are rows in the lecture room. So that means if I consider the number of rows x, let number of rows equal to x. The number of students in each row, how many? X, because number in a row as there are rows in a lecture. So obviously x. So therefore total students how many? Number of rows into number of students in each row. That means x into x. X square is the number of students. But already we know number of students. So x square equals to 10404. From here, to know the value of x, we have to find the square root value of this number. Yes. So now what will be the square root value? Square root value of this, we can follow the division method. 10404. So start pairing from this side. So 1 is alone now. So we have to give 1. Yes, 1, 1, then plus 1, that is 2 here. Next pair, that is 0, 4. So obviously here 0 not possible. So that's why you have to take the next pair, that is now 404. And since we are taking 2 pairs at a time, we know the rule what? We have to put 1, 0 here. So it is 10 now, and double of 10 means 20 here. Yes. So obviously 2, because 404. So 102 is the square root value. 102 is the square root value. So question was, how many students are there in each row? So we got the answer, 102 students. Therefore, in each row, number of students equals to 102. I think this part is clear. Yes. So now, example 4. There are 500 children in a school. For a PT drill, they have to stand in such a manner that the number of rows is equal to the number of columns. How many children would be left out in this arrangement? That means here 500, this number is not a perfect square. It is clear from the question. So first we have to know what is the nearest value, perfect square value, that is 500, and should be less than 500, because would be left out in this arrangement. Yes. So what is the nearest value? That means to know that we have to find the square root value. I know it is not perfect square, but we have to proceed the long division method to find the square root value. That means 5, 2. 2 means 4 here. So 100 and plus 2, that means 4 here. So obviously we have to give 2. That is 16. 16 is the remainder. That means, what is the value? 16 is the remainder, means 500 minus 16. That is 484. 484, that is a perfect square. Yes or no? The question is, how many children would be left out in this arrangement? So 16 students, answer will be 16, because this number is perfect square and that is 22 square. From here we are getting 22, so 22 square is this. So our answer will be here 16. This is the answer. 16 students, but 16 children would be left out. Would be left out. Clear? So example 4 completed. Now example 5. Find the largest number of 4 digits which is perfect square. Largest number of 4 digits which is perfect square. That means first you have to know the largest number of 4 digits. What is that? 4 times 9. This is the largest number of 4 digits. But we have to find which is perfect square. That means first you have to check it is perfect square or not. If it is not perfect square, then we have to find out the perfect square. Clear? So to know that, we have to follow the long division process. Clear? So 99. 99 means 9 square 81, 10 square 100, obviously 9 here. So 9 if I give 81, then 8, 18 is the remainder, then plus 9, that is 18. So next pair 1899 now number. I told you here for the new digit leave 9, for 8 we can leave 9, 18 that means 1. So maximum 10, but not possible, we can give maximum 9 here, no? So 9 if we can give here, 9 if I give, then put 9 here, 9 is 81, 9 8 72 plus 8 80 and 17 here. Then 8 and 9 1. So 198 is the remainder. That implies it is not perfect square. So what will be the answer? Therefore, largest 4-digit perfect square number, how will get? Subtract the remainder, that is 198, subtract 1 and 0 here and 98. So 9801 is the largest 4-digit number which is perfect square. I think this part is clear, students. Now example number 6. Find the smallest number of 5 digits which is perfect square. So now we have to find the smallest number of 5 digits. So first we have to know what is the smallest number of 5 digits? 140. This is the smallest number, but we have to find the perfect square number. So again we will proceed by long division process. Start pairing 1 here. So obviously 1 you have to give. Then yes, largest 5 digit which is perfect square. So here 2 zeros and here 2 zeros again. Yes or no? So here 1 means double of 1 0. So you have to put 0 here. If we put 1 here, then 2, yes, double, but since 0 here, so you have to put 0, 0 into 0 everything. Now next pair. So again if we follow this method, 20 plus 0, that is again 20, but again 0, so with 0, 0, 0. So if we follow division method, then we are getting this. So 100. So this is the smallest number of 5 digits which is perfect square. 10,000. It is 5-digit number and it is a perfect square because its square root value we are getting 100. Is it clear? Now example number 7. Find the length of diagonal of a rectangle whose sides are 18 cm and 24 cm. Length of diagonal of a rectangle. We know rectangle means each angle 90 degree. Yes or no? So we have to find the length of diagonal. We know the sides 24 cm and 18 cm. So since it is right angle, so applying Pythagoras theorem, we can find the length of diagonal. Yes or no? So basically length of diagonal will be length of diagonal square root of 24 square plus 18 square. Yes, centimeter. So that means 576 plus 324. So how much adding? 10, 3, 7, 10, 1 and 9. So 900 square root of 900 centimeter, that equal to 30 centimeter. Yes or no? So length of diagonal is 30 centimeter. I think this part is clear. Now we will discuss the next point, Pythagorean triplets and triangular numbers. Pythagorean triplets. Pythagorean triplets. Pythagorean triplets and triangular numbers. Pythagorean triplets are sets of three positive integers that satisfy the formula a square plus b square equal to c square, commonly used to represent the side lengths of right angle triangles. Is it clear? That means the right angle triangle ABC, three numbers of the right angle triangle. So a square plus b square equal to c square. If we get this relation, then ABC are called Pythagorean triplet. For example, 3, 4, 5, 8, 15, 17, 5, 12, 13, these are the Pythagorean triplets. Yes, but we have a formula to find the Pythagorean triplet. If we know one member, then other members easily we can find. If x is any positive integer and greater than 1, then the Pythagorean triplets we can find using this formula. What? X square minus 1, 2x and x square plus 1. These are the Pythagorean triplets. Is it clear? Next, if x is an even integer and greater than 2, then we can use this for the Pythagorean triplet. X comma x square by 4 minus 1, and next is x square by 4 plus 1. But when x is an odd integer greater than 1, then the Pythagorean triplets are this: x comma x square minus 1 by 2, and another is x square plus 1 by 2. Is it clear? So to find the Pythagorean triplet, if we know one member, then other members we can find applying this formula. I think this part is clear. Now, primitive Pythagorean triples. These are triples where ABC share no common divisor other than 1. That is called primitive Pythagorean triple. For example, 3, 4, 5 is primitive triple, whereas 6, 8, 10 is not primitive triple, because 6, 8, 10 have a common divisor 2. That's why these Pythagorean triplets are not primitive Pythagorean. Clear? So this is the difference between primitive Pythagorean triplets and other non-primitive Pythagorean triplets. Clear? So from a primitive Pythagorean triplet or triple, we can find many more Pythagorean triple, multiplying each value by a number k, where k is any positive integer greater than 1. Is clear? So for example, 3, 4, 5 we can write 9, 12 and 15 multiplying by 3. Like this we can find many more Pythagorean triples or triplets. Clear? So now triangular number and perfect square numbers. Triangular number and perfect square number. So now our fourth point is this part completed, this part completed. Now the last part I am going to finish: triangular numbers and perfect square numbers. Yes, triangular numbers are numbers that can be represented as a triangle. Especially I can say it can be an equilateral triangle, or we can form a right angle triangle also. The numbers forming a sequence having nth term, whose nth term will be n into n plus 1 by 2, known as the triangular numbers. The first triangular number is 1, second triangular number is 3, third triangular number is 6, and fourth triangular number is 10, and so on. Clear? Now let us see the pattern of these triangular numbers. The first triangular number is 1, 3, Next is 3, 6, 10, 15, 21 like this. But see the pattern here, how we are getting here. 1 plus 2, 3. 3 plus 3, 6. Then 6 plus 4, 10. 10 plus 5, 15. 15 plus 6, 21. So what will be the next triangular number? 21 plus 7, 28. Yes or no? So next triangular number will be 28. So easily we can find all other triangular numbers. But here, one thing notice, why I wrote 0 here? So from this triangular number, we can find the number of handshakes. Say number of person 1, then how many handshake? One person can handshake? No. So that's why 0. But when there are 2 persons, then how many ways 2 persons can handshake? Only 1. Yes. When 3 persons, the number of handshakes will be 3. When 4 persons there, the number of handshakes will be 6. When 5 persons are there, the number of handshakes will be 10. So from this triangular number, we can find the number of handshakes. Is it clear? Easily we can find. Now, I told you triangular number. Why? See here, triangular number 1. Next triangle number 3, see here, it is forming an equilateral triangle. Next triangle number 6, see again, it is forming an equilateral triangle. Next triangular number 10, see here 10 circles, but how we are writing this, how we are placing these circles, and see here how they are forming an equilateral triangle. So first circle 1 circle here, then 2 circles, then 3 circles, then 4 circles. That means we are increasing 1 circle in every row, and that's why we are getting an equilateral triangle. So since the numbers are forming equilateral triangle, then we can say it's a triangular number. Clear? Now example number 8. Find a Pythagorean triplet whose one number or one member is 14. Since one member is 14, so we can use, since even number, so 2x equals to 14, that means x equal to 7. Clear? So I told you what is the formula? When 2x is the one member, so x square minus 1 and x square plus 1 will be the other member. So according to this rule, x square minus 1 is giving 49 minus 1, that is 48, and x square plus 1 is giving 49 plus 1, that means 50. So that means the Pythagorean triplets are here 48 and 14 and 50. These are the Pythagorean triplets. Clear? Now, example number 9. How many handshakes are possible in a group of 6? How many? Just now I have discussed. Group of 6. So group of 6 means number of handshakes will be 15. From this pattern, triangular number pattern, easily you can find. So answer of this question will be 15. So 6 person number of possible handshakes. Number of possible handshakes is 15. Yes or no? Now so I am ending class here, and if you have any more queries, you can contact me through my mail ID manoj@TIGPSE.in, and if you see my next video, and I think this will be the last video, then we will get many important sums which are important for competitive exams. So my request is, please watch my next video. Thank you, students. Have a nice day.